All right, so today we are going to be looking at in front of you. So therefore, as we're going through today's demonstration and notes, you're going to be filling in your note sheet, and I'm going to be asking for volunteers. Your cellular respiration or photosynthesis and cellular respiration sheet that we did on yesterday, where you did the drawing, you want to have that out so that will assist you. Alrighty, so let's go ahead and get started. I don't need this light flashing in my eye. So I'm gonna turn this on. All right, looking at your note sheet that you have in front of you, it's titled Cellular Respiration Notes. Someone go ahead and volunteer and read the overview portion for me. The portion titled Overview. Brianna, go ahead and read it loud. Energy. Yeah, it tastes good. Like, for instance, I had a Frisco milk for the first time last week. How many of you had a Frisco milk before? From Steak and Shake? Sorry, Stefan is making that face because he knows what I'm talking about. Everybody's like, how many had Frisco milk? If you had one, you would have been like, what it tastes like? What it tastes like, Stefan? Like heaven, right? It's delicious. I have not tasted some patty pie. So, how many have heard about patty pies yet? Yeah. How many of you tasted it yet? What it tastes like? It's good. I called Walmart to get a patty pie. Everybody's sold out. Everybody is sold out. Like, really. Anyway, so back to my train of thought about food. Again, it tastes good and all that great stuff, but we don't eat it because it just tastes good. We do eat it for energy. Now, some food we do eat because it tastes good, but essentially it does give us energy. Continue. However, trying to use food molecules like glucose to run our body is like trying to get candy from a coin-only vending machine with a $5 bill. Can you do that? No. If it only takes quarter, how many of you ever done that before? You got some dollar bills on you. You go to the vending machine and it only takes quarter. Your life is over, right? It's like you don't have no money and you got money sitting right there and heaven is sitting right in front of you, you can't get in. Go. Your cells can only use the chemical bond energy stored in. Now here's where you use your notes. Again, keywords. Your cells can only use the chemical bond energy stored in. What was that thing that we talked was energy on your notes? ATP. Very good. Now read the sentence with the correct word. Your cells can only use the chemical bond energy stored in ATP molecules to run cellular operations, just as the coin-only vending machine will only work with coins. All right, underline the word energy in that sentence. Continue, please. Therefore, the cell must change food molecules like. What are the food molecules that you get that you use for energy? Glucose. So again, it says, therefore, cells must change food molecules like glucose into. What are we changing that glucose into? ATP, energy. What is ATP also known as? Who remembers? And it probably is in your notes from yesterday. I did tell y'all before, but I just said it in passing. I did not have you write it down. I don't know if it's on your note sheet, but I know it was definitely within the video. Does anybody remember? Okay. Well, ATP stands for adenosine triphosphate. And I know I provided 3 spaces because I wanted you to put tri in another space because that means something. How many phosphorus do you think is going to be in this molecule? 3, because of the word tri. So adenosine triphosphate is what ATP stands for. Also known as Energy. Whenever you hear ATP, you think of energy. Before we write anything else down, just want to use your brains to do a little bit of review. ATP occurs where? In the, what have we been talking about? But in our body, but in our what's of the body? In our cells. ATP is also known as energy. So what part of the cell do you think is going to occur? Mitochondria. Why? Because it is the powerhouse of the cell, meaning it provides what to the cell? Energy. Does that make sense? All right, very good. All right, so this whole thing that was just mentioned up top about we eating food, getting energy, using glucose to change it to energy, also known as ATP, what is that whole process called? Say it louder. Cellular respiration. That is what we are talking about. All right. Just using a little demonstration here. Here I have a candle, just a regular ordinary candle. And here I have a lighter, regular lighter, the ones that you would use if you're lighting the grill at home. So what I'm going to do is I'm going to light this candle. What provided the spark to start the candle from burning? The pressure that's used in there, and then inside of here is little things that strike together. It's like a little match that strikes together so the fire can come out so that I can light the candle. So basically, in essence, it's the match. If I use the match, it would be a match. But if I'm here, I'm using the lighter. The lighter provided the spark to light the candle, correct? All right. What provides the fuel for the candle to burn? The wax. The wax that if there was nothing, no wax for this candle to burn on, it probably wouldn't continue to burn unless I had something else for it to burn on. Does everyone understand that so far? And I'll bring it all back together because some of you are looking like, what does this have to do with what we are talking about? Is the burning candle giving off any type of energy? How do you know? Yep, it's warm. And what would cause me to do that? My nervous system. And what in my nervous system? My neurons, but they're going through what type of things to tell me, hey, move your hands, stupid. The feedback mechanism. Very good. All right, getting back to this. All right, so he said that he knows that it's giving off energy because there is heat. How else do you know? Because you're not up here. I could tell you all day long that this is cold, and you wouldn't know if you had not ever experienced fire. You were like cavemen. Fire. All right. So how else do you know energy? Nope. You're on the right track. There is light. Remember, energy is in several forms: sound, light, heat, and sound, light, heat. So we see light there, so therefore we know that it is giving off energy. And the type of energy it's giving off is heat, ouch, hot, and light that we see. All right, so what happens if I do this? Is Isaiah the only one? Brianna and Emmanuel the only ones? Nobody over here? Guys, over here, take your hands, face them this way, and do like this. Send them some waves of thinking waves. Did you guys catch? Hey, do it again because they weren't ready. Put your hands up. Be ready. Put your hands up for the rebound. All right, ready? Let's go. Rebound. Tadarian, rebound. Come on. All right. So over here, why is it that my lovely candle burned out? Is it because it said, hey, I don't like y'all anymore? So what did I do, though? I did put something over, so what did I remove? I removed oxygen. There was no oxygen present for that heat to still be there. So it used up all the oxygen. All right, so we understand that oxygen is efficient for energy to be there, correct? The energy that we saw there was light, was fire, and we knew that energy was there because it was heat and it was light. It needed what to be there? Oxygen to be there. As soon as oxygen was removed, there was no energy. Does that make sense? Hold your breath. I want to come on the candle. Now let me ask you this. Stop holding your breath. Now if I said hold your breath and run around this room, With your breath being held, would you be able to do it?
Yes.
No.
Would you be able to do it as efficiently as you would be able to if you were breathing? No. Why? I know you were passed out, but why would you pass out? Because there is no oxygen. You don't have the energy to run around the room because you are not giving yourself oxygen. That makes sense so far. All right, so then looking at your paper on your notes, let's just start tying some of this together. We said that the spark that was needed to light this candle and provide energy was the lighter. That was the spark, or if I had matches, it would be the match. What is the spark that would actually get cellular respiration started? And we didn't talk about it today, but we talked about it before. And we talked about it when we talked about cellular biology or chemical biology, and we said these things are needed to start a chemical reaction. Because the process of you taking in glucose and changing it to energy, you changed it to something else. So therefore, you had a chemical or a physical change. There was a chemical change. In order for something to be changed, that is changed from one substance to another, that is a chemical change. Your body uses something to be able to start that process. What is it? What does your body use to start those processes? I'll give you one example. How many of you like milk or cheese on a Frisco milk? And if you ate a Frisco milk, then you understand the word milk means that it has lots of dairy in it. Now, if you were a certain person that could not eat dairy, then you couldn't go to Steak and Shake 3 days in a row and ask the lady for one and have to hide your face because you would have been shamed for being there the day before and the day before, and she is the same lady at the window. Why does she work every day? I digress. But if you were that person that could not eat Frisco milk, then you would not be able to go and get one because your body could not process that cheese, and you would be walking around like this. What is that process called if you cannot digest it? Lactose intolerant. But if you can digest it, then you will be fine. So what is there that is allowing your body to process this or break this dairy up? Enzymes. And enzymes are always necessary to start a chemical reaction. Remember, they start chemical reactions. So what's needed to spark cellular respiration? Enzymes. Yes, you need to make sure you write that down because your first thing says to start to get cellular respiration started is. So then it tells us that energy is released when glucose is burned in the cell. Do we believe that to be true? When we eat something, which you all just came from lunch to eat, which you probably will have a snack before today's game, Shania, would you? Have a little bit of something? But if you could get one, would you like to have a little bit of a snack before the game? You would want to get that because you want to provide yourself with energy. And it just tells us here, energy is released when glucose is burned. Whenever you eat, that provides you with the energy to stay awake. Even staying awake uses a lot of energy. Although some of you, and some of you will agree, because when you're like this, it's so hard to stay awake because it uses a lot of energy. All right. What kind of energy is released? This is review. It sounds like I'm being redundant. But what kind of energy is released when you use glucose to burn, when glucose is burned in the cell? We've said it a million times already today. Nope. ATP. Thank you, Justin. I know it's, and some of you were reluctant to say it because you're like, Rick said that, so it can't be the right answer. Well, guess what? It is the right answer. All right. Here's a little bit of a thinking. Why isn't heat released in large quantities in the cell? So that means, why isn't it just like sparking up everywhere in all cells at all times? This is common sense thinking. Some of you probably won't give me the right answer because you're not going to be thinking common sense-wise. You're going to try to be thinking too deep. But I'll read it again. Why isn't heat released in large quantities in the cell? It is basically applied to that specific area, but let's say, let me ask you this again. Why is it only applied to that specific area? Why isn't it released in large areas in that specific area? Not necessarily. Meaning? It would be too much. If I wanted to warm up the house, if I just wanted to warm up this room and our heat went out in the building for some reason, and I I needed to use candles to warm up the room. Would I be lighting candles in every area of this room? Why? It would be too much. It would be overbearing, and it would damage the room. It would be too hot. So again, why isn't heat produced in large quantities? It would damage the cell. It would kill the cell. And if the heat is increased in areas, then what else is going to increase? Your what? If heat in your body is increased, what's increasing? Your body temperature. And what should your temperature be? 98.6. So it will kill your cell, and your temperature should only be 98.6. After you eat, your temperature does increase because you are burning off that glucose, so you're producing heat. So you do get a little bit of a fever, but not to the point where you're sick because your body is burning off the glucose, making energy using that glucose. But if it does it in too much quantities, then you will produce a fever, and you will kill your cells, and that's not good. Do we understand that? All right, let's move on. Make sure I'm staying in the right track. All right, so what is the gas needed to break down glucose into ATP efficiently? What gas did we say was needed for energy? Oxygen. So make sure you put that. And then another review. Where in the cells is this glucose broken down to provide energy? Again, where in the cells, and I'm not reading it word for word on your paper, but in other words, where does cellular respiration take place? In the mitochondria. And we know that because it's the powerhouse. Who can spell mitochondria?
I can.
Spell it for me, Tadarian.
M-I-T-C-A.
Don't miss the letter. Mitochondria. Good. Con is a CH. All right. Mito, con, the k is a CH, not a K. Andrea. Don't name your kids that. So you're going to call me Andrea for sure. No, don't do that. All right. Knowing the fact that it is using, and here's where you're using your notes from yesterday, understanding the fact that it is using this necessary gas, and that necessary gas is what again? Oxygen. Understanding that it is using oxygen for this process of cellular respiration. What type of respiration is this? Say it. Aerobic. Remember, this is on your notes. This is aerobic respiration. Now, this is from yesterday's viewing of the video, but it's not, you didn't actually write it on your notes. So let's see how many of you may have retained a little bit of this information from watching the video. How many ATPs can be gained if a glucose molecule is completely broken down with oxygen? So the food that you take in is all the way broken down. You got your hand up? I'll move over here. Right here. Thank you. How many do you think? It is 36. 36. That's just a little trivia point. I would put a little star on it because it could pop up as a bonus question maybe. All right. Now, at the basketball game, you're playing basketball. Coach is keeping you in because you're the star player, so you're staying in. There's nobody listening. So coach is keeping you in because you're the star player. You're the star player. Star player. You might be the star player on the bench. Please, but you're the star player on the team. What happens when you are the star player, though? Do you get much rest? No. Coach takes you in for a second, takes you out for a second, puts you back in. And the whole time, you might be like, and you still running, you still going, and you still playing, but then you're like, you kind of taking some air, trying to get some oxygen into that system so that you can have more energy. Now, in that process, you have not been able to stop long enough to get enough oxygen to get into your system, but you are still going. And the fact that you are still going, your body goes into another mechanism that's not cellular respiration because you are not using oxygen. You are still moving because of what process? It is on your notes. What is that process called when you do not have that oxygen to be able to break down that glucose in your body and create the energy that you need? Somebody anybody other than Brianna and Justin. Again, guys, put your hands up one more time. Put your hands up one more time. All of you. If all of Mike, you got to do it too. Come on. Catch the rebound. Catch the rebound. You got it. All right. Fermentation. Fermentation is what type of respiration? Anaerobic. Make sure you write fermentation. It's on your paper. You should have wrote it from yesterday. Anaerobic. You can also put the process glycolysis, and that's on your paper as well. All of those are anaerobic. Mike, cut it out. Now, where in the cell does this take place? Where? On the cytoplasm. Make sure you write that down. Now, why is it important for us to have oxygen to be able to break down the glucose for energy? Remember what I just showed you. Without it, it wouldn't be effective. Now, you do have energy because remember I said coach is putting you back in and taking you out only for a second and then putting you back in. But you still can play the game. You are more tired right there. Move your feet, Isaiah. You are more tired than the other players, especially the person that's been sitting on the bench a little bit longer, but you're still able to move. So you still can work without the amount of oxygen, but not having the amount of oxygen makes you less efficient. So the question then asks again, explain why is it important that oxygen be present to break down glucose so that you can be more efficient in making ATP. Does that make sense? What about over here? Yes, you can be more efficient. All right, I'm going to light our candle again. I'm going to be asking for a volunteer. I want you to put your hand in the
I want to do it. I want to do it.
You're supposed to say, oh, no, that's not what we're doing, Pyromaniacs. No. All right, so the candle is now lit. What we're going to be doing in a moment, we're going to be doing a demonstration, and this demonstration is going to be using, I can never say this quickly. Where do you put bronchitis? Bronthomol, blue liquid, which is an indicator. And this indicator is used to detect carbonic acid. So it's going to be used to detect carbons. Put your hand down. It's going to be used to detect carbon. So we've used indicators before. We've used the pH indicators. We've used indicators for the disease. And that indicator means that it shows the presence of what it's looking for. So this, again, is an indicator for carbonic acid. So it's going to be looking for carbon molecules whenever they are present. All right. So when carbon molecules are present, the substance, actually, let me tell you, what color is this substance? Right here, maybe you can see it. And I'll put it on here so that you all can see it. Well, actually, it's not. Because what's in the air right now? Oxygen. Is it oxygen here? I'm sorry, that's a lie. Carbon dioxide, because we're all breathing. So the moment that it comes from this container and it goes on there, it was blue, but then it turns green because it's protecting. But it is blue in the container. Actually, yeah, it turns a little yellow because we are high in carbon, which it's on my finger, so it did turn a little bit yellow. All right, so I'll need a volunteer before we come up. I call the volunteers. This right here is representing the fact that we are burning glucose, the fact that we are breaking down glucose. When we break down glucose, it provides us with Energy. We know that energy is present because we feel it. All right. So what's being made is what? Energy. So far we know that energy is being released from the breakdown of glucose, but the only way that we can break down this glucose is we also need what? Oxygen to do so. So we've taken in oxygen. We've actually taken in some glucose because we just ate. We see that energy is being produced. You always tell me, you told me on yesterday, because when you put your hand like this, everyone do it, blow out, that gas that you are blowing out is what? Is it? In your dragon? Carbon dioxide. You told me that to be true, but let's test it to be true. Testing it with an indicator for the Bermuda blue liquid, and we're going to take a look and take oxygen away, and we're going to trap it. So I need a volunteer. Jemiah's coming, just raising her hand so anxiously. Now, come right here so that you can be closer to the fire. Now, what we have to do, it very quickly. We'll go to this side. We're going to place this on here. You are then going to clasp this with your hand, okay? So you need to trap any of the gas that comes out as soon as the fire goes out. So you need to put your hand like this. All right? What kind of hand she got? All right. Actually, come over here because so these people can see. Everything right here. Are you ready? Now, this might be hot. It might burn a hole through this. And you got to determine how long. Is that okay with you? She said that's okay. So just so y'all know. What are we removing again? Oxygen. Are you ready? Oh. Oh my God. Remember, it was blue. Still blue. We didn't trap enough of the gas that was in it. It is changing. So, therefore, we know that what was released with the what was released with the still can't talk. What was released with the absence of oxygen? Carbon dioxide, because this detects carbon, so there is carbon in the air because we see that it's detected it by changing a greenish color. Any questions from that? Okay, thank you very much. Give her a round of applause. She's looking for that hole in her hand. It'll happen later when you go to sleep and you wake up. It'll be there. You have a hole in your hand. All right, so looking back at our note sheet, what gas is given off as a waste product of cellular respiration? And let's change this statement. Instead of saying what gas, cross off gas. And let's just have it say what is given off as a waste product of cellular respiration. What is it? Carbon dioxide. Hold on, we're not there yet. What is the chemical formula for carbon dioxide? Nakaya. I know, what is it? CO2. Make sure when you are writing CO2 that the C is capital, the O is capitalized, and the 2 is a subscript, meaning it's written below. Sub means below, script means writing. It's a subscript. Now, again, put your hand like this. Before you do anything with that hand, take a deep breath in. You have started the process of what? What type of respiration? Aerobic respiration. So through cellular respiration, you started. You provided your body with oxygen. Your body is using that oxygen to break down what's already in your system from lunch, which is what? Food. And what you get from that food? Glucose. It's breaking it down to be able to give you this. Everyone do this. Everyone do this. To give you the energy that's being released. I'm not sure Shania ate because she doesn't have much energy. Then we're breathing out. So we're going to test it and see. All right, we're going to test it and see. Put your hand over your mouth. Take a deep breath out. Rub your hands together. Is it moist? So we know that there's a presence of what? Water. That heat was carbon dioxide. We tested it. The liquid that comes out is water. So we know that the byproducts are carbon dioxide and water. Any questions so far about that? All right, then flip your papers over to the back. Now it tells us to write a balanced chemical reaction or balanced formula for cellular respiration. Now balance means that what's on the reactant side means what goes in is equal to what comes out. May not be in the same form. It better not be in the same form because this is a what type of reaction? Chemical reaction. So it may not be in the same form that it went in, but it better be the same that comes out. This is why it's very important that you go to the bathroom every day because what goes in must come out. And if it doesn't, you got a problem. It better not come out in the same form because then you got a problem. All right. So let's look up here and get a balanced chemical reaction. Before you write anything, let's just review what we're talking about. Don't write anything just yet. All right. So we know that we took in oxygen. This is all being taken in, which means we're writing it on the left side, okay? In lunch, you also took in glucose. We took in some food. Which you broke it down and used it for what you needed. And then, right now you're sitting in class, and the fact that you're sitting here looking at me, tapping your pencil, rolling your eyes, blinking your eyes, and even breathing is showing me that you are releasing what? Energy. So this arrow means yield to means that you are releasing. You gave off some energy. When we took our hands and we cupped it on our mouth, we let out what? We let out carbon dioxide. And we also let out water. Nope, you're not writing anything yet. All right, so now that we know what the reaction is, now we need to write it in a balanced equation. First of all, what is the chemical symbol for oxygen? O. Now you're writing. Yep, on the line. Where else was you going to write it? Okay, where else was you going to write it? I'm just curious. I just need to know how your brain works. All right. I'm going to give you some information that you might not already know because you haven't taken chemistry in detail. But oxygen always works with a twin. It can never work by itself. It has to be with the twin. So it's actually going to be O2. You also took in this glucose. We talked about this formula earlier in the year. If you don't know it, you probably should be getting into looking in your binders to see if you can tell me what the formula for glucose is. O6, very good. All right, so we then let off what? Energy. Energy is also called what? ATP. We also let off, and carbon dioxide is the chemical formula in the kind of what? CO2. And we let off, everybody, the chemical formula for water? H2O. Now, we need to check if it's balanced. We have 2 oxygens over, well, we have 8 oxygens over here. 2 plus 6 gives us 8. Over here we have 2 plus 1 gives us 3. It's not balanced at all. And I'm not going to teach you how to balance equations because of the simple fact that that's chemistry and we're not going to go into all of that. But what we're going to do is we're going to add a 6 here and the 6 in front of the H2O. And we're also going to add a 6 in front of the CO2. So now it gives us 6 times 2 is 12 plus 6, 18. Here you have 6 times 2 is 12 plus 6, 18. Our oxygens are taken care of. Any questions about that so far? Here we have 6 carbons. Here we have 6 carbons. See? 6 carbons, that's the coefficient. Here we have 12 oxygens. 6 times 2 is 12. So we have 12 hydrogens. And we've already taken care of oxygens. It's balanced. We don't need to balance energy because energy is not what? Starts with M. Matter. These things are matter. They can be created or destroyed. I'm sorry, cannot be created or destroyed. ATP, energy, is not matter. It doesn't have mass or take up space. You understand that? Any questions about this? All right, Chemistry 101. All right, moving on to number 2. What are the materials necessary for respiration to take place? You told me. What are they? They first have to be started with what? Nope. How does that fire get started? With a spark. What's our spark? Enzymes. You need enzymes. What else do you need for respiration to take place? Oxygen. And what else? Glucose. Enzymes, oxygen, and glucose. Looking at your formula, what is given off during cellular respiration? Everyone should be able to, actually over here, let me get somebody over here right there and tell me. What's given off during cellular respiration? Why are y'all looking at me like I'm crazy, like we didn't just do it a million times? I showed you, I modeled it, I said it, I read it, I danced it, we wrote it, drew it. Okay, ATP is given off, what else? Carbon dioxide and what else? Water, very good. Ooh, you got it. All right. What is ATP? Energy. Write down that word. What does it also stand for? I mean, what is the actual name of it? Adenosine triphosphate. Write that down. Now we're going to draw and label it. Now, adenosine is something that is present in our DNA. It is made up of other elements, carbon elements, it has a bunch of other elements with it, but because that elemental compound is so complex, it's adenosine, we're not going to write down that complex elemental compound, but we are going to write it as what it is, adenosine. And this is us drawing it. Now this, again, remember I just told you it's a large elemental compound. It's a bunch of C's connected to other oxygens and things of that nature. But we just combine it into being this one box saying adenosine. That large elemental compound is connected to a sugar. This sugar is called ribose. Ribose is also located in our DNA, deoxyribonucleic acid. Now we've taken care of the adenosine portion. What's missing? Triphosphate. What's phosphate? 3 what? 3 who? Okay, speak up. No, you just said something. I want you to say it. Stop second guessing yourself. 3 what? But phosphate is not an element. It comes from the element known as phosphorus. So we're going to have 3 phosphorus. 1, 2, and that's what your adenosine triphosphate looks like being drawn and labeled. Any questions about today's lesson? All right. And this concludes today's lesson.